Greetings, math fans. All right, so today's lesson is more about limits, and what we're going to do is we're going to talk about limits by direct substitution. Okay, so sometimes what happens is you might have a hole someplace, but remember, as I told you in the previous lesson, is that holes don't matter for limits, right? I can get really close to a hole, but I'm never going to get there. Remember, if it's f of some value and I'm at a hole, it could be undefined. Okay, but if I'm approaching a hole with a limit, it doesn't matter. I actually look to see what is my y value. So sometimes I can actually just do direct substitution, find a value, even though I'm not there, I'm still plugging that value in because I'm saying, man, I'm getting really close to that value. So let me plug that value in and see what's going on. Okay, so let's take a look at the first example here. It says limit as x approaches 3 of 2x plus 4. And this is basically linear. Okay, so I have no issues at all with this graph. In fact, if I actually graph this, 1, 2, 3, 4. Okay, the y-intercept is 4, right? And then it's up 2 and over 1. So this is what my graph looks like, roughly. All right, and then if I said x approaches 3, so I'm approaching this value right here. I have no issues at all with this graph. In other words, there's no holes, there's no like jumps anyplace, there's no asymptotes. Okay, so I have no issues, which again means no holes, no jumps, or jumps from one to another like a piecewise function, no asymptotes. Okay, but it's none of those. So basically what I can do is I can actually do direct substitution. I can say, oh, well, let me just plug it in. 2 times 3 plus 4. So 2 times 3, 6 plus 4, the answer is 10. All right, and that's the answer to this problem. It's equal to 10 because I can just plug it in. Now, if I said what's f of 3, you would tell me, oh, well, I just plug a 3 into there. 2 times 3 is 6 plus 4 is 10. You get the exact same thing. That's not always going to be the same case where the f of some value is equal to the limit, as we saw in the previous lesson when we looked at those graphs. Okay, but if there are no issues at that point, you can just plug it directly in and come up with your limit. Okay, let's take a look at the next one. The next one is a quadratic. And there are no issues with that as well. I mean, I don't know exactly how this looks, but I know it's kind of, it's got some parabola shape, right? And I have no issues. I don't care where you are on this graph. Now, if I'm at 2, which is maybe over here, let's just say it's right there, there's no issues. There's no holes, there's no jumps, there's no asymptotes or anything. So I can just do a direct substitution. So I have 2 times 2 squared plus 5 times 2 minus 3. Okay, so that gives me 8 plus 10, 18 minus 3 is 15. So that's the answer to that problem, which again is same as f of 2, right, by plugging it in. Because there are no issues at all with f of some value, there's no hole there, you can plug it directly in. Okay, not bad so far. Okay, this next one, limit as x approaches 4 of 8. Well, think logically. Remember, this is my y value. These are y's. Okay, so if that's y's, isn't that the same thing as saying y equals 8? So I go 1, 2, 3, 4, 5, 6, 7, 8, and it's a horizontal line, isn't it? And then I can say, well, when x gets closer to 4, which is right here, so it gets closer to 4 this way and this way, because we are talking about two-sided limits here now, math fans. Okay, what's the value of y going to? Well, isn't y going to 8? So the answer is 8. These are actually really easy problems, but you know what the number one mistake for this one is? Kids answer 4 for that. Boo! X is going to 4. I want to know what y is going to. Okay? So, I mean, it would be kind of silly almost for you to say that, the answer is 4. Because what's the 8 for then? It's just kind of hanging out there, just looking pretty? Okay? So you got to use that 8 someplace, right? And that's exactly what's happening. The y value is 8. Okay? So don't answer 4. Okay. Let's look at the next one. Limit as x approaches negative 3 of x plus 3. Well, do you guys agree? I mean, I can plug it in, no problem, right? Negative 3 plus 3 is 0. Everybody okay with that? Okay, good. So 0. Not wrong. Well, what do you mean? Why is that wrong? Well, let's actually investigate this a little bit. Let's actually make a picture, because I do have an issue, because there's places where it's not defined, right? When that square root is negative, you can't have a negative square root. There's no imaginary numbers here, so you just can't graph it. Well, if you guys remember, if I graph this, your function is going to look something like this. Okay? Kind of a sideways parabola, right? And, well, you're still like, well, I still don't understand. It still could, when I approach -3, isn't it still 0? Remember, guys, this is a two-sided limit. So that means I need to investigate what's coming from the right side, so from -3 positive. So let's actually write that out. It's limit as x approaches -3 from the positive side of f of x. Don't you guys agree that's 0, right? Because you're approaching y equals 0. Well, what about limit as x approaches -3 from the negative side? Well, it's not even defined here. Okay, so if it's not defined, remember, this is like an endpoint. This is one of the problems that we did towards the end of yesterday's lesson. It's an endpoint, so since it's not defined there, you would say this is dne. So then what is the limit as x approaches -3, which is a two-sided limit? Well, that's going to also be dne. Okay, because again, this is a two-sided limit. In order for the two-sided limits to be, in order for a two-sided limit to exist, the one-sided limits have to be equal. These are definitely not equal, especially because this does not exist for the one-sided limit. Okay, so sometimes you actually have to look at, you got to look at the graph. Just by plugging it in doesn't always work. Now, it worked for the first three because there are no issues at all with that graph. A linear, a quadratic, and actually another linear, a horizontal line, there's no issues any place in the graph. This one you should say, oh, a square root. Okay, it can't be negative. What if it was the cube root? Cube root is beautiful because I can take the cube root of a negative number, positive number. I have no issues there. I can take any limit and just do direct substitution. I don't have to worry about it. Okay? All right, so let's move on here. Next function, limit as x approach is 3 of this nice little rational function. Well, you're going to look at it and you're going to go, oh man, if I plug it in, I'm going to get a 0, and that's bad. Okay, but guys, remember, if you just do direct substitution without kind of investigating a little bit, you're just saying, I'm basically ignoring that it's a limit. All right? And what I want to do with this problem is I want to try and simplify. Okay, so try to simplify the expression. So simplify expression. You always want to try and do that, and especially if you recognize, you see a quadratic on top, you should always look to see if you can factor that. And so sure enough, I factor it, I get x minus 3, x plus 2 over x minus 3. So that's my new limit. And of course, you can see these cancel. Guys, as soon as you cancel something, we've talked about this already when you make graphs, as soon as you cancel, you need to say, oh, there's a hole here. So I need to say there's a hole at x equals 3. Really, really, really important. Okay, so my new function is really limit as x approaches 3 of x plus 2, because everything else canceled. And this is now linear. So remember what I told you about holes? Holes don't matter for limits. If I actually said what's f of 3 for this function, you can't plug a 3 into the equation, into the new equation. You have to say, oh, geez, there's a hole there. So if there's a hole there, you would say it's undefined. But my limit as x approaches 3, I don't care about that hole, so I'm just going to plug it directly in there. And my answer is 3 plus 2, or the answer is 5. That's what y is going to. Okay? So remember, with a hole, if I say f of that value means it's undefined. But a limit means you approach it. I'm approaching the hole. I'm never getting to the hole, so I don't have to worry about it. I just want to know what's going on either side. And so that's why I'm approaching the value of 5. Okay? So really, really important, you simplify it. Don't look at the problem right away and go, oh, geez, x minus 3, if I plug it in, it's undefined. You should say, oh, geez, I better simplify it first. Okay, so that's the answer for this problem is 5. All right, let's take a look at the next one here. Given a nice little friendly piecewise function, I wanted to find the limit as x approaches 1 of f of x. So what you need to do is you need to graph it, a piecewise function. So you guys should remember that, right? If I plot a point, it's going to be 1 comma, I put a 1 there, and I get negative 1, because 2 times 1 minus 3, right? And then I put a 1 into here, and I get positive 1. So I need to make a graph, because I need to know what's going on with this function. And if I graph it, let's see, so we got 1 negative 1 is a solid dot, and 1 positive 1 is an open dot. Now, you know what? I don't really care what the graph looks like. I just know that it starts, when it's the open dot, it's going to the left somehow. And when it's the solid dot, I'm going to the right. Okay, I could graph it, that's fine, but it doesn't really matter. Okay, so, and truly the only way to do this problem is by graphing it. So really, if you don't know what's going on with the graph, you can't simplify it like we did for the first, or for number 5, where you actually factored it. You actually must graph it. You got to prove it somehow, what the limit is. So remember, this is a two-sided limit. So let's look at both sides here. Limit as x approaches 1 from the negative side. Well, you know how I just did the squiggly? I mean, I could truly have graphed it more accurately, but because I don't necessarily care what the graph looks like, I'm just approaching from the negative side. And so if I approach from the negative side, what's the value of y? Well, do you guys agree the graph value of y, so this is of f of x, it's equal to positive 1. And the limit as x approaches 1 from the positive side, which means I'm coming this way, well, it's equal to, so that's of f of x is equal to negative 1. Okay, so because these are not equal, what can you tell me about the limit as x approaches 1 of f of x? You would tell me it does not exist, because the one-sided limits are not equal. Okay, really, really important you kind of sketch it out to see what's going on. Okay, let's keep going here. Number 7. Once again, you're going to look at this and you're going to go, if you can do direct substitution, you try it. Always try it, because maybe you don't have to do any manipulation and do all that work. But if I say limit as x approaches 0, sine of x, oh, right away I see, oh geez, sine of 0, 0, right? So it's undefined if I actually just plugged it in directly, but of course limits can never be undefined. So in this problem you can't do direct substitution. Remember, since sine of 0 equals 0. And when I say it, I'm saying f of 0 is undefined. So what you try to do is you try to simplify it so I can actually try to plug it in. Okay? So if I simplify, and you're like, well, how do I simplify that? Well, I know tangent of x is sine over cosine, so I can do that. I can say sine of x over cosine of x divided by sine of x. And if I want to divide that out, do you guys agree? It's that divided by sine of x over 1, which allows me to do this times the reciprocal of that, right? Times 1 over sine of x. Oh, sweet! Sine of x is cancel, and I really get 1 over cosine of x. So you guys should recognize in the original function, I couldn't plug it in. So I really have a hole. I have a hole actually at x equals 0. So if I said, what's f of 0? Remember, f of 0 means I have a hole. So f of 0 is undefined. Okay, because of the hole. But if I do the limit as x approaches 0, again, I don't care about the hole, but this is my new function. So it's really limit as x approaches 0 of 1 over cosine of x. Well, I can plug it in now, because what's cosine of 0? It's 1. Sweet! So my limit is equal to 1. All right? So I truly have a hole here at the coordinate of this hole is 0, because I said it was at 0, 0 comma, and I plugged a 0 into this equation here, and it was a hole at 0 comma 1. Okay? But my limit is equal to 1. All right, so that's just some examples of direct substitution. Again, sometimes the first 3 problems didn't have to do anything. You just directly plug it in. And then and sometimes you have to manipulate it to simplify it, to simplify it, and then you can do direct substitution. Okay? Okay, so now let's talk about some properties of limits. We've got them all typed out here for you. And these are actually pretty intuitive, but let's talk about each one. Okay, so the first one is just sum rule. No, actually it's the sum rule. Okay, and it's basically saying limit as x approaches c, and you have basically two functions here. And what I'm saying you can do here with the sum rule is I can actually split up into two separate limits. Okay, so it's pretty easy. So again, if those two limits are together and it's addition, I can split up to two separate limits. Same thing with the difference rule. I can split those up into two separate ones with subtraction between them. Okay, of course, sum rules with addition between them. Product rule is the same thing. Okay, if it's multiplication between the two terms, I can separate it to separate ones. Okay, and then of course the product of those limits. And same thing with quotient being division. I can separate it to two separate limits. Okay, this is actually pretty important because sometimes you're going to get a complicated limit and you actually do need to separate it. So a couple more here. The power rule makes you feel very powerful, but the power rule is, it's kind of a little hard to read this, but this is to the r over s power. So in other words, it's to an exponent or to a root. Basically what you do with that is if I take the limit of that, I can basically write it, I can take the limit first and then raise it to a power, as opposed to taking the limit of that f of x to a power. I can just take the power outside of it. So find the limit of f of x first and then raise it to a power. I'm allowed to do that. Okay? And the last one is called the constant multiple rule. And basically, if there's a constant in front of a function, I can take that constant out of it and put it on the outside of the limit, which I did right here. Okay? So that kind of is nice because sometimes you'll have a nasty number in front, whatever. I don't have to worry about the constant because limits don't change the constant. It's still constant no matter what. Okay? So let's just actually use this a couple times. Again, it's pretty easy to do that. But if I said limit as x approaches 2 of this quadratic function, I can write this as limit as x approaches 2 of x squared plus limit as x approaches 2 of 2x minus limit as x approaches 2 of 3. Okay, again, it's direct substitution. 2 squared is 4. 2 times 2 is 4. And remember, limit as x approaches 2 of 3 is just what? Is just 3, right? Don't say it's 2, it's 3. So you get 8 minus 3 is 5. Okay. The next one, I'm going to show a couple steps here. I can say that's limit as x approaches -1, and I can say of 2x, and this is to the third power. Okay? So I pull that on the outside of the whole limit, and then I can do one more step here. I can say limit as x approaches -1, and actually I'm going to put the 2 in front of that because it's a constant multiple rule. I'm going to pull that out to the outside here, and then that, and then I'll have just x, right, because I pulled that out, and that's to the third power. So basically this one here I did the power rule, and this one I did the constant multiple rule. Okay, so let's figure everything out here. It's basically saying 2 times what's the limit as x approaches -1 of x? Well, it's just you put a -1 there for x and you get -1, right? And that's to the third power. So 2 times -1 is -2. Cubed is -8. Okay, that's pretty easy, right? But that's just kind of some of the properties and limits, and again, we're probably going to use that a little bit more as we move on in the chapter. Okay, last type of problem here, math fans, is actually pretty easy. If I give you guys these limits, So I actually have defined the limit as x approaches 2 of f of x is negative 3, and the limit as x approaches 2 of g of x is 2. Then I can just apply it. So like for this one, I'm actually going to use my properties of limits. Limit as x approaches 2 of 3f of x over g of x. I can say, well, I can use my quotient rule, the quotient rule, and I can also use the constant multiple rule, right? So I can say 3 times, I'm going to show my little bit of work here, 3 times limit as x approaches 2 of f of x divided by limit as x approaches 2 of g of x. Well, those are given now. Okay, they're given right here, so let's plug them in. So it's 3 times, what's the limit as x approaches 2 of f of x? Well, it's negative 3. And what's the limit as x approaches 2 of g of x? Oh, that's 2. Goes right there. Okay, and so we get negative 9/2. That's really pretty easy to do this, okay? Especially when they're defined and they just kind of hand them to you and then you just kind of apply it. So this next one, just so we can keep those visible up here, limit as x approaches 2 of g cubed of x. Well, that's the same thing as saying, using the power rule, I could say limit, or the power property, right? Limit as x approaches 2 of g of x, and that's to the third power. Okay, so again, I can pull this right off of here, the 2, because that's what limit as x approaches 2 of g of x is, 2 cubed. So the answer is 8. Okay, pretty easy. And then the last one is limit as x approaches 2 of f of x plus 5. So that's using, just using sum rule. No, it's using the sum rule, and that's equal to the limit as x approaches 2 of f of x plus limit as x approaches 2 of 5. Well, again, come back up here. What's limit as x approaches 2 of f of x? Well, it's right there. It's negative 3. So we substitute that in. That's negative 3. And this one, I don't have to look at the chart because it's constant. What's the limit as x approaches 2 of 5? It's just 5. So my answer is positive 2. Okay? It's pretty easy. So they said the lesson is pretty mellow. It's limits by direct substitution. Sometimes you have to manipulate it first, as in number 4 with the square root. Sometimes you have to investigate. Always look to see like a critical point. What's going on? If there's some issue, maybe a hole, or it's not defined, or an asymptote, you want to investigate that, and then you know, maybe make a graph, or maybe you actually just simplify it using algebra and try to figure out the limit that way. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.